So this is question 7 from the 2019 Cambridge International Education Winter Exams, paper 1-2. You can find a link in the description below to an image of this question, which of course I recommend you do before watching any video. This question is about a three-dimensional shape of rectangles and parallelograms, but really it's about the vectors in between these points. We're going to use these vectors to answer some questions, and we're just going to answer some questions about the vectors themselves. I've done my best to draw this shape on the board. I hope it's roughly accurate enough for us to work with. So we have, the question describes already these shapes. The bottom shape here, OABC, is a rectangle, as is the top one, DE, F and G. We have the sides here, O, A, E and D is a parallelogram, and so is the one at the back. And I guess the shape in between would be a rectangle, but on the side. We don't really need to interact with that though. And they ask us simply to express this as a vector. Now they do give us some vectors. I better write them out first. O to A, well no, I'll put them here. OA is equal to 6I. Now I never put in the plane either. That's I. We have, let me just check which way they do it. J and K. So that's J, I and K, or IJ and K more accurately. So OA lies right on this I. In fact, OA is equal to 6I, so a unit vector is 1. This is 6 unit vectors along. OC also lies on this. Do they give us anything for OC? They do. OC is equal to 8J. But OD does not lie perfectly on the K line because it's a parallelogram. But they still give us OD. OD is equal, so it's not quite on it. It's going to be made up of a couple of other vectors. Again, they give us all this. This is 2I plus 10K. So it's 2I and 10K. So really, if we looked at it side on, it would look something like this. We go across 2 and up 10. That's how we find it. That's how we can use a vector. Going this direction in a vector is identical to going this way. And we're going to use that to answer the questions they ask us. They ask us to find two of the vectors, PB and PQ. Okay, I should state that P is halfway up here and Q is halfway from G to F. Okay, with all that set up ready, we can actually start the question. Although I should say about that setup, it's going to take you a long time. That was a lot of information in this question. Don't be afraid to spend your time reading it, understanding what the shape is, understanding of what they're telling you it is. And do not start the question until you have a good understanding or until you get a little desperate on time. Okay, so PB, they want to get at the vector, sorry, P to B, yes. Starting at P and ending at B. That would go across the middle of this three-dimensional shape. But the good thing about vectors is we don't have to do this. Going this vector, time doesn't matter in vectors. Think of it as traveling from P to B. Vectors don't care how you get there. A vector is happy for you to go P to O. It's then happy to go O to A. I'm just trying out some things. Multiple different paths will probably work here. And then A to B. That's one of the paths I could take. I can see other paths to take. P to B, D to E, E to F, F to B would also work. But I think this would be the neatest and simplest. So let's see, do we have numbers for all of these? Because I want to turn PB into I, J's and K's. But I don't have them. But PO. Now I don't have PO, but I know PO is half of DO. And let's see, OA, we have that. Let me just leave that for now. And AB, I don't have AB, but I can see AB is identical. It goes the same direction and the same length. That's all that matters in vectors. It goes the same direction and the same length as OC. So instead of AB, I'll put in OC. Now, DO. I don't have DO, but I have OD. Just different direction, same length. So I can replace OD with half or minus a half O. DO, I can replace DO with OD. Just change the direction, changes the sign. That's all that it does. And plus OA and OC. Keep putting these arrows in. Right, I can start just filling in some numbers now. Is equal to minus a half 2y plus 10k. Just need to multiply that by minus a half really. Plus 6i and plus 8j. I'm just taking these numbers from here. Okay, let's add up all the i's. Let's see, there's half of 2, that's 1, minus 1i and 6i is equal to 5i. All the j's, there's only 8j here. And all the k's, let's see, there's minus 5k. Minus 5k. So that's the vector to get from P to B. So what it's telling us to do is it's telling us to go across 5, it's telling us to go back 8, and then it's telling us to go down 5. Which does roughly make sense, and I do recommend you think that through a little. Across 5, back 8, and down 5. That's what this is telling me to do. So I'm getting my directions from here. I means to go to the right. J means to go into the board. And K means to go up. So I is right, J is into the board, and K, or minus K, is down now. So if K is up, minus K is down. Okay, so that is PB. Let me do the next one a little bit faster. So this is 4 marks out of 9. So this is pretty much half the question. P and Q. Let's see. P and Q. Where is P? Here's P and here's Q. Let's just go as direct as we can. That's equal to PD plus DG plus GQ. If you keep these letters like this, where it's DD, GG, and the P and the Q are the same as there, that's a vector will always equal when we do that. Okay, so PD is half of OD. Half of OD is I plus 5k. DG, let's see, DG is the same direction and length as OC. So that's plus 8j. And what was the last one? GQ. GQ is half of OA. Same direction, but half the length. So half of OA, where's OA? Here it is. Here, half of 6i is 3i. Let's clean this up. All the i's, we get 4i. All the j's, 8j, and all the k's is 5k. That's the two answers here. PQ is equal to this, and PB is equal to that. That's all of part one. Yes, that's part one answered. Part two, determine whether P is nearer to Q or B. I think I'll rub this out first before we get into that question. Okay, to repeat myself, part two says determine whether P is nearer to Q or to B. So basically what I'm wondering is the length of the distance between P and Q and the length of the distance between P and B. See which is bigger. So we just do both of them. The length of PB, we write that like this. 2 lines across it. And the length of PB, and we do that by just squaring each of these numbers. Add them all together and get the square root of it. So the length of PB is 5 squared plus 8 squared plus minus 5 squared. You don't have to put the minus there. The square will make it disappear every time. And yeah, let's do both of these on top of each other. PQ, the other question. The length, so this is the distance between P and B, and this will give me the distance between P and Q. We'll find out which is closer. So this is just 4 squared plus 8 squared plus 5 squared. And again, this is the square root. We just add all these up. 25 plus 64 plus 25. I have the answer here somewhere. Is equal to square root of 114. And if I add all these up, 16 plus 64 plus 25 is the square root of 105. So which is closer to B? And it's a good idea to say this. B is closer. Just write down the answer you've got. B is closer. Oh, I'm sorry. Q is closer. 105 is smaller than 116. Yes, Q is closer, is what I wrote down there. Alright, so that answers part 2. There's only 2 marks for that. There's only one simple thing to do. I think your formula at the back of an exam would give you this information. And this is really just a 3-dimensional Pythagoras theorem, sort of, is one way to look at this. Okay, part 3. Use a scalar product to find out the angle BPQ. Where are we? BPQ. Let me write that again. So here's Q, here's P, and here's B. So BPQ. We're looking for this angle in here. We'll call it theta. Now, they've given us lots of information. PQ. We know this vector here. Sorry, here's P, here's Q, and here's B. We know this vector, PQ. We know that gives us lots of information. We know this vector, PB. They even gave us in the right direction because the scalar product actually tells us something about the angle in the middle, which is good because they asked us to use the scalar product to find this. So we have a formula. It will be in the back of your exam in a formula table. The formula tells us that the length of this multiplied by the length of this, good thing we already worked out some of that, and multiplied the cosine of this as a cosine. Yes, cosine of this is equal to the scalar product. So let me write that out. Bit of room here. We have PQ, doesn't matter which way we do it, PB, we're just multiplying here. Cosine of theta is equal to the scalar product. We write the scalar product like this, just a dot. The dot product, we also call it, PB. And all this we can do, I'll say how to do this in a moment. This multiplied by this, it's just these two. So a calculator will do that for us at some stage. I'll leave it like this until the very end of my question. Cosine theta. So is equal to, what's the dot product? Here is the two vectors. If we're doing this, by the way, we need the vectors to point away from the middle one here. And they do already. So the dot product is just the i's multiplied, the j's multiplied, the k's multiplied, or the number in front of them. So the dot product is simply 5 multiplied by 4, and 20. 8 multiplied by 8, 64. Minus 5 multiplied by plus 5 is minus 25. Let's clean this up a bit more. We have cosine theta is equal. Add all this together, we get minus 5, we get 59. Divide by both of these guys, we get square root of 114 multiplied by the square root of 105. And that's it, they just want us to find the angle. So we just need to get the inverse cosine. So theta is equal to the inverse of cosine of this number here. So 59, I'm sorry for squeezing this in, over 114 multiplied by 105. So you just put that into a calculator. Put that into a calculator, you will get an answer. Let me write it up here. Theta is equal, oh yeah, it came out very neatly. Theta is equal 1, that's in radians. It's in radians. I know a lot of students don't like using radians. That's fine. Just make sure your calculator is in one or the other. It doesn't ask you which, so you have a choice. It would come out as 57.4. It wasn't exactly 1, by the way. It's 1.00 something. But it rounds off to 3 significant figures to be 1. That's why this is not 57.3 is closest to 1, but it's not exactly 1. Just in case you're wondering. Alright, so that's all the answers. If you have any questions about that, hopefully I've explained it. Vectors can be really annoying to some people because they're so new and they're weird, but honestly they're not too difficult. Mostly it's just simple multiplication at most points. It's usually just following a path. I really believe a 10-year-old child could be taught vectors probably easier than a 15-year-old child, because 15-year-old students are used to doing things the same way and they've never seen vectors before. Whereas if I taught to a person new, it's very simple. It's just following a path. It's following a path. Basically, it just means distance doesn't matter in lots of ways. Anyway, if you have any questions, put them in the comments below, and I'll do my best to get back to you. Have a good day.